All right, guys, so what we're going to talk about today is we're going to go over the oscilloscope and the signal generator. Okay, I'm going to give you kind of a quick and dirty explanation of it all, and then hopefully that'll help you guys through the online quizzes that you guys have. Okay, so what we're looking at here is we are looking at the screen, okay, or the CRT of the oscilloscope itself. I want to explain this first so that when we start going over the oscilloscope and all the different adjustments, maybe this will help you guys kind of get through that and understand what I'm talking about. So we're looking at the screen of the oscilloscope here, okay? The screen is divided into 4 main quadrants, okay? Now, across the screen, left to right, that is the time portion of that function, okay, or the time reading of your oscilloscope. The vertical part of the screen is the amplitude or amount, okay, of your reading, okay, value, if we're going to be reading voltage a lot with this, so this is the amount of voltage that you're reading, and then this is the time it takes for it to complete its cycle, so to speak, or that's the time of the signal that you're looking at on your screen there. The horizontal subdivisions, there's 10 divisions across horizontally, and there's 8 divisions vertically. So in this quadrant right here, you're looking at 5 by 4, 5 by 4, 5 by 4, and 5 by 4. Okay, it just so happens that each one of those sub little quadrants there, okay, are 1 centimeter by 1 centimeter measurements. Okay, so there may be some questions that are asking you how many centimeters. There may be questions asking you how much time, how much amplitude, how much voltage, something like that. Okay, so hopefully this will kind of help clear you up on that. So when we look at the signal that we're seeing on an oscilloscope, that's called a trace. Okay, now, like you guys have seen on the videos, DC voltage, if you look at it on an oscilloscope, what you see is if it's at 0, you'll just see a straight line there, okay? And then when you turn the DC on, what you're going to see in general is just something that looks like this, to where the voltage turns on here, and then it goes up some amplitude, and then you've got that maintained voltage, okay? It's direct current, so nothing is changing current-wise with DC voltage, okay, unless you physically change it somehow. Now, what we see with AC voltage is we are going to see this type of signal right here. We've got current going one way, and then now current going the opposite way, okay? So we'll call this the positive going current and the negative going current, okay? What happens is you've got a certain amount of voltage at the peak here, and then a certain amount of voltage at the peak there. But this is the current going positive and going negative. Here in the States, we are going to get this complete cycle from 0, positive, back across 0, negative, and then return to 0 again. That is one cycle, okay? That is completed one cycle. So in the US, this happens out of our walls 60 times every second, okay? We are at 60 hertz, okay? Now, that is what hertz is, cycles per second, okay? So we've got that happening 60 times per second. So what we see here in the States is 60 hertz coming out of our wall, okay? That's this right here, positive, negative, then back to 0, okay? That is one cycle. Hertz is cycles per second, and so we see this happen, this waveform happens 60 times every second, okay? Now, when we look at this signal here, what we're able to do is we're able to take these little 1 centimeter by 1 centimeter blocks or boxes, and we are able to make measurements as to the amplitude, okay? Amplitude here, and then the time across, okay? So, amplitude and time, remember, 8 divisions total vertical and 10 divisions total horizontal. Now, let's look at our oscilloscope here, okay? Now, here's the CRT or the screen. That's this right here, okay? And you can see all the divisions here, and that it's 5 in each quadrant or 10 all the way across horizontally. And you can see that it's 8 vertically or 4 in each quadrant vertically, okay? And these will be all 1 centimeter, okay, by 1 centimeter. Now, if we look at this, this looks very daunting and scary, okay? But what we have to do is we have to break it up into these different sections, and then it becomes fairly easy. This is why I wanted to go over what we're kind of looking at, okay, with our oscilloscope before we look at this. Now, we're going to go through each one of these sections, okay? First section, of course, I want to start out with is this power section, okay? That is nothing more than just the power button as far as we're concerned. Now, I'm gonna mainly hit on the things that are important to you guys, okay, as far as these oscilloscopes are concerned. But the power switch. Now, this is CRT here, intensity and focus. So, the intensity is just going to adjust the brightness of your screen and your signal, okay, that you're getting on your screen. Focus, you can adjust this focus and make your signal, okay, a little bit clearer and more defined. Sometimes, depending on your signal that you're getting, it may be kind of fuzzy. So what you want to do is adjust this focus to where you get as thin of a line as possible. The thinner the line we have on our trace, the more precise we can make those measurements, okay? Now, so that's what this is. Intensity is the brightness of your trace, and focus is just that. It's how thin of a line your trace is. Okay, so coupling source here. We want to have it on auto, okay, and channel 1, which is not a huge deal for us. Trigger level, what that's doing is that is basically the adjustment to as to where you want the oscilloscope to pick up your trace, to start your trace basically. So you want it to start, if you can, at the 0 point here. Okay, this middle line is your 0 line. So you want to, that's just an adjustment as to where you want the oscilloscope to start seeing the trace and then pick it up so that you can see it on your screen. Okay, hold off, don't worry about that. Okay, position. This is going to adjust where your trace is appearing on your screen. Okay, so we want to make sure that we have it centered as much as possible so that we can see as much of the trace as possible. Okay, that's where that position is coming in there. Now, we're going to go down here to this vertical section here. You've got 2 different sections within your vertical section. You've got channel 1 and you've got channel 2, okay? Channel 1 is this input right over here, okay? This is your channel 2 input. Now, you can basically just divide it down the center, and these are adjustments over here for channel 1, and these are adjustments over here for channel 2. Now, this little portion here in the center, you've got channel 1, channel 2, dual, and add. Okay, channel 1 is selected here. That means whatever signal we've got coming in here, we have got, into the oscilloscope, we have got that signal coming into channel 1. So that's the one we want to look at, so we switch to channel 1. Okay, if we have a signal coming into channel 2, then we will switch that to channel 2 and we will be able to look at the signal coming in on channel 2. Now, we can also switch to dual. So if we've got two signals, one coming into channel 1 and one coming into channel 2, we can actually look at both of those traces on the screen at the same time and compare those. So if we're trying to compare voltage or time on two different signals, this is how we would do this. Then the dual, I'm sorry, that was the dual. The add is we would actually physically, internally, the oscilloscope adds the two signals together and we can look at a combined total signal of those two coming in, okay? Now, over here, we'll look at the channel 1 side because the channel 2 side is going to be the exact same just for the other channel. So, over here, position, okay? That is going to be the vertical position. So, we've got our trace signal coming in, and we don't want our trace necessarily down here or way up here. We want it right in the center so that we can see where it's going to cross that 0 line, okay, and then where it comes back to it there at the 0 point. So what this is going to allow us to do here is this is going to allow us to move that signal up and down on the screen so that we can get it positioned just how we want it to make the most exact measurements. Now, the volts per division portion here, okay? Now, this is going to adjust the value of each one of these squares vertically, okay? You've got 5, 2, 1, 0.5, 0.2, 0.1, 50 millivolts, 20 millivolts, 10 millivolts, and 5 millivolts, okay? So, the smaller value that you give the volts per division, the larger your signal is going to be, your trace is going to be, okay? What we want to do is we want to fill as much of the screen with that trace as we possibly can. If we could get it to where the trace was basically at the very edge of the screen here, okay, and then it went up to the top, back down, to the bottom of this section here, and then right back up, okay? That would be ideal. That is going to give us the most precise measurement of our signal coming in. Sometimes you can't do that. A lot of times you can't do that. But that would be the most exact way of measuring our signal. So that's what that volt per division is going to do for us, okay? Is going to select how we want the signal or the trace to look on our screen. And that is going to do that by adjusting the value of each one of those squares there, okay? So if we've got it set to 0.5 volts, okay, that means if we've got 8 divisions total on our vertical scale, if they are 0.5 each, that means from the bottom of the screen here to the top of the screen, that is going to be a total of 4 volts. Okay? Because each one of these is 1/2 volt. So that is going to be 1/2 volt, 1 volt, 1.5 volts, 2 volts, negative half a volt, negative 1 volts, negative 1.5 volts, and negative 2 volts. Okay? So that is going to be the full scale there, and that'll be a total of 4 volts top to bottom, okay? Measurable. Now, that's how this works here. You get into that millivolt range. So what you're doing, if you've got so many, if this is set to a 50 millivolt scale, okay, and we've got this signal that we're looking at here, this is a positive going signal of 200 millivolts. This is a negative going signal on this other side that we drew, the red one, okay, of 200 millivolts, a negative going signal of 200 millivolts. So that would be a total of a 400 millivolt peak to peak, okay, value. From this peak down to that lower peak, okay, that is going to be a total of 400 millivolts. And 8 divisions times 50 millivolts, that's 400 millivolts, okay? So that's this time selection mode here, okay? Now, over here on this side, you've got a switch. If you're looking for AC voltage or DC voltage on here, that's what you select here. This ground is going to give you a straight line across, okay, the screen, and that, what you can do is set that to ground, okay? You'll get that straight line, that flat line across the screen, if you will. And then here, this position, you can adjust that position to where it's right over that 0 or that center line. And that way, when you switch back to your AC, you will be able to see that the signal that you've got coming in, you will know that it is exactly along that 0 line, okay? So that takes care of this vertical section here. Now, time base, okay? Just like this vertical adjustment here, this time adjustment is going to adjust how much value you have here across in your horizontal section. Okay, remember, amplitude and time. So time is going to adjust the value of this horizontal portion of this block to a specific value. And you've got everything from 2 seconds over to 0.1 microseconds per division, okay? So what you'll do is if this across, okay, is 50 microseconds per division, okay, if we've got it set, well, this one's set to 20, so we'll just say it's at 20 microseconds per division, okay? So if it's set to 20 microseconds per division, that means each one of these 1 centimeter by 1 centimeter blocks, the value of that one block is 20 microseconds. So if I look at the entire time across the whole screen here, that's going to be, remember there's 10 sections, so that's going to be 200 microseconds, okay? So my total time it takes for me to complete this one trace or this one signal or this one cycle is going to be 200 microseconds because that's what I've got it selected to there, and it takes up the whole screen. Now, if, and a lot of times this will happen, on both amplitude and time, you want to see as close as you possibly can this signal going from the complete left-hand side of the screen to start there and then ends at the right-hand side of the screen. And you want to be able to adjust it to where the peak is at the very top and then at the very bottom, okay, if you can. Now, that is going to give us the most precise way. What you're going to see a lot of times when you're looking at a signal is you won't necessarily be able to adjust it just perfectly how you want it. So what we might end up seeing is something more like this, to where you've got a signal that looks something similar to that, okay? And granted, I didn't draw this perfect, but what we're going to see is a signal that looks something like that, okay? Now, we will adjust the time and amplitude to get it exactly how we want it on the screen, but we can still take measurements just like this. We can count the number of blocks from this point to this point, and that gives us the amount of time it takes to complete a cycle. And then we can count the number of blocks from this point to this point. Okay? And there is our amplitude right there. Now, in these blocks here, okay, you can see that there are smaller divisions here in each one of those blocks. Each one of these blocks is divided up into 1, 2, 3, 4, 5 divisions. So there's 5 subdivisions vertically and 1, 2, 3, 4, 5 divisions horizontally. So this allows you to break it down even further and get even more of a precise measurement there. Okay, that pretty much covers everything on the oscilloscope. I know I kind of went over it quick, but rewind the video, watch it again, and hopefully that'll help you out. Okay, now we're going to move on to the signal generator. Okay, so what we've got here with this signal generator is, again, this is divided into multiple sections here. This is our display or readout here. Of course, our power switch, okay? Our frequency, okay, which is the cycles per second. Frequency is given in hertz, all right? So, how many cycles per second here? That's what we're going to adjust. Now, that is going to show up, that readout here is going to show up on our screen, okay? This is the range. So if we're wanting to look at a signal that is 3 kilohertz, okay? 3 kilohertz, so 3,000 cycles per second, all right? So what we would do is we would adjust that to the 10 kilohertz range, okay? This range here, each one of these adjustment points is the top end of that range, okay? So if we want 3 kilohertz, we'll have to adjust it to 10, okay? We'll have to adjust that range to 10, and then we'll use our frequency knob down here, okay, to adjust that to 3,000 or 3 kilohertz, okay? Now, function. For 99% of the things that you guys are going to be concerned with, you're going to be using this regular sine wave function, which is that type of trace that we're seeing right there. Okay, so we will be looking at the sweep here next. Okay, now that is, you're not really going to use this very much. That's kind of adjusting how fast it's going across the screen here. Okay. Your input, okay? What this is going to do is this. You can do some different things with this. We're really not going to look into that though. But the output is what we're going to be concerned with, okay? We're going to be coming out of here with a BNC connector from that main, okay, over to the oscilloscope, okay? So we'll connect here. Okay, and we'll go into the oscilloscope, and then we'll be able to look at what type of signal that we're adjusting for here. Okay, offset. That is giving us the ability to offset the trace or the signal that we're putting into this, and then amplitude. Okay, amplitude is what's actually going to adjust the amount of voltage that this signal generator is putting out, okay? Now, the way we're going to do that is if this is supposed to be 4 volts peak to peak, we will adjust our oscilloscope here, okay, to hopefully 1/2 volt per division, okay? And we will adjust this amplitude, okay, to where we've got it filling up the whole screen, okay? 4 volts peak to peak. We're going to have a 1/2 volt for each division. That'll give us 2 volts this way and 2 volts that way, and that will be basically a screen top to bottom, okay, that is that your signal is tracing from top to bottom, top to bottom, top to bottom. Okay. Coupling here. Okay, we want to be on external AC. All right. We don't need to worry about the CMOS adjustment. Okay, so the main things that you need to be concerned with here on the signal generator is the readout, power switch, frequency, okay, the range, function. Again, you're just going to be on that sine wave, okay? Input, don't really need to worry about right now, okay? Sweep, we really don't need to worry about that right now. Offset, not that important, okay? You may use that a little bit, but not critical, okay? Amplitude's going to be important. Remember, that's going to adjust how much voltage we're putting into putting out of our signal generator. And then the main connection here, okay, is what we're going to be coming out of and going into our either our circuit or the oscilloscope to make adjustments. Okay, so that right there pretty much covers the signal generator and the O-scope for us. Okay, if you guys have further questions, don't hesitate to email me through Moodle. Okay, thank you guys.